So I'd like to introduce now TimSpurway, who's visiting us from our silver sponsor, Chango. And he's team lead of large-scale data.
LSD.
Apologies to anybody who gives me anybody who gives me a title more than 5 words at this point is probably going to get it wrong. But he's going to be talking about dancing with big data using Inferno and Disco. So let's give him a big round of applause.
Thanks. So Chango's an ad tech company, and we process a lot of data. And so we need to do MapReduce, mostly on logs. And we've open sourced a framework on top of the open source Disco framework called Inferno. And that's what we're going to be talking about today. So just to preface it with a talk about Disco, because without Disco, there is no Inferno. Disco is an open source MapReduce platform. It's implemented in Erlang and Python. So the Erlang part, for those of you who don't know Erlang, it's a functional programming language that is really good at distributed systems. And the Python part is what you actually write your MapReduce jobs in. So jobs are written in Python. There's no Java. I mean, the first question we often get is, how come you're not using Hadoop? It's a valid question. There's no XML in Erlang or in Disco. I mean, you take a look at the front page on the Apache project for Hadoop, and it's all about writing these Yarn applications, and there's like hundreds of lines of Java, and there's descriptions of these XML files, and after you get it installed, you just download Disco, get it running, and it works. So it was a fairly easy choice. We wanted to try and get something running quickly and see if it would work. From an architectural perspective, Disco seemed to fit. Erlang seems like a really good fit for this type of system. It takes care of all those things that, the Beam architecture allows you to build systems that are distributed fairly easily and all that. So why Disco? Simplicity. It's a few thousand lines of code of Erlang. The distributed file system part of the software is a tag-based system. It's built on top of the Unix or Linux file systems, so it's really simple. Basically, it's a really interesting and small framework. So what's Inferno? What we wound up doing is we wrote a lot of MapReduce code. So you write your map, you write your reduce, and we've got a lot of different types of logs and a lot of different types of calculations or queries we want to do. We wound up writing a lot of kind of the same stuff over and over again, and thought, is there an easier way to do this? There's a lot of boilerplate and so on. So Inferno started out as kind of a rule-based approach to doing MapReduce. We've got some, a lot of types of jobs that we like to do. One of the things we want to do is take logs and populate a data warehouse kind of automatically. So Inferno's running. There's rules running in there that are trying to summarize data into a data warehouse. Optimistically looking for new data, spawning off a MapReduce job to summarize that data and insert it into a data warehouse that our front-end applications, reporting applications, and so on, can then go and take a look at and, So Chango's ad tech company. We do search retargeting. We're on the exchanges, the ad exchanges. So there's about 10 exchanges we're on. We get hundreds of thousands of requests for displaying ads per second. This translates into billions of records per day. And we've got about, 50 to 100 rules that we run regularly on this data to target different dimensions of the data. So we're crunching a lot of data. I've got 50 billion records per day here that we process. That's how many we receive. A lot of those records we go over multiple times. I'll talk about key sets later and a strategy to reduce the number of times we have to go over each record of this data, but it's a lot of data. Our cluster has about half a petabyte of storage, which, that's not that much, but we only keep about 2 months worth of data online at any given time. So we're dealing with quite a bit of data. Inferno can be used, it has multiple facets. The first facet is it's a rule-based query language. So you want to sum up some dimension of your data. You want to select keys and values from certain logs and do summary type queries, filtering, and so on. So it allows you to do that. It's a DSL for logs. But also there's the use case that we have where we want to summarize the data once, insert that summary data into a data warehouse, and then archive it to say, let's not process this data again, so that we can, do the slicing and dicing in a data warehouse. We also use it for distributed computing tasks. Inferno rules a lot of times you just want to do a lot of things to a lot of URLs, so that's another use case of Inferno, is just distributed computing. So we deal with a lot of logs. The first kind of version of Chango used queuing systems and stuff like this to try and summarize data in real time, and we quickly got buried under the amount of data we were having to process. So we simplified our architecture into log-based systems, and we standardized on JSON. So every single log that we deal with is a JSON log. Every single line is a valid JSON expression, I guess, if you will. There's a standard way, like our logs are fairly structured. We try and keep naming of fields and stuff across the different types of logs consistent and so on. And this really pays off. If you spend some time refactoring your data, we found you reap a lot of benefits from that. Just to talk about how Disco stores files. It's a distributed file system. You set a replication across your cluster, so replication factor, and it allows you to have every single chunk or log file replicated so that you can use that replication to gain concurrency. Really, it's a basic tenet of MapReduce is you really need to have replicated data in order to get concurrency. Disco uses what they call, let's talk about Disco for a while, a chunk, which is when you chunk into Disco, it will compress it and you pass it a tag. Now, they call it a blob, so the blob is just a chunk of data, and your tags, you can have a one-to-many relationship between tags and data. So each tag can hold many blobs of data, and it's fairly flat. A tag is just a string. By convention, we use colons within the tag name to denote different parts, like where is this log coming from, what's the date of the log, what format is it in, and so on. A lot of the operations in DDFS allow you to work on aggregates of prefixes of tags. So if you wanted to process all of your So here's a log. At the very top is the tag name, and this is an actual tag we use. You can see it's from a thing called a collector, and it hints at search data that's for a particular date. I've simplified a lot of this stuff to protect the innocent, but it's a typical log. That's one line of data in the log, and it's a search on Google. Here's an Inferno rule. So what I'm trying to say is, this is a query type search. It's saying, give me all the searches in my log by data source, by where did it come from. So we see you have source tags. That is, where in DDFS am I getting the data? You have a thing called parts preprocess, and I'll talk about that in a sec. And then you have keys and values. Anyone familiar with MapReduce knows that keys and values are an important part. During the map phase, your data is segregated and hashed out to a number of partitions based on your key. So these are keys that are in the JSON. And then in your reduce phase, you sum things up or you aggregate based on your values. I just did this before. There's actually a bug in the value parts. But the idea is you run the rule. Down here is a Linux command line or of executing Inferno, executing this rule. So there's a command line component. You're basically saying, run this -s on, this is my cluster, and you tell it, what rule you want to run. The -r at the end gives you a date range. So Inferno is aware about, when we look back at the tag over here, by convention, we always have a date at the end. So we're able to do, and Inferno expects this kind of structure in the tagging, so that you can do -r5 will give you 5 days worth of data, and you can index in and select ranges and so on very easily. So that's one simple use case of Inferno, and that's the query DSL. Give me a summary of my data. So, like I said before, Inferno is rule-based. It has a concept of key sets. Key sets are an abstraction. We found that the first version just had rules. And we were finding that we were running the same kinds of operations on the same data, but with kind of different dimensions. And we're trying to, cut down on the number of times we have to iterate over all of our data. So a rule can have kind of sub-rules in it. So that when you run it, it actually only runs over the log once, but will generate multiple results. And that's a key set. And I won't get into an example of that, but it allows you to, really efficiently process your logs into a number of different destinations or get a number of results. So another feature of Inferno is this, we call them automatic rules. And it's basically a long-running daemon that the rules opportunistically look for new data to work on. They take incoming data, run the rules on it, store it out to a database or back end, and will archive the processed tags. This is useful for stuff you only want to, that you want to summarize and only get data on once. You specify data sources as DDFS tags. I talked about doing date ranges and so on. And we talked about key sets. Again, a part in Inferno is basically each line of a log. It's kind of the lowest the lowest value that we have. And we talked about the key parts versus value parts and how those correspond to map and reduce. There's a number of other features in Inferno. We're going to run out of time, but there's a lot of other features that allow you to manipulate, filter, or generate more data or less data at the line-by-line level. There's an archiving feature. We touched on this before. It's a mechanism built into Inferno that allows you to only process one log one time. Here's another, this is an example of an archiving or automatic rule that will go over top of an impression log, process it, save results to a particular table. If we wanted to introduce multiple different destinations for results, we could introduce multiple key sets in here, which would allow you to run over the log once and shoot data out to multiple different tables in your back end. Okay, so that was kind of a whirlwind tour of Inferno. I hope I explained it okay to you guys. It's open source. It's on Bitbucket. We're going to probably be moving it as well onto Git. A lot of people have been asking for that. Docs are on rtfd.org, and there's Python, a group for it as well, and Google Groups. All right.